In this video, we are going to be looking at inverse trig functions. And if you remember from algebra, the inverse has this notation. So when I come to the sine, I'm going to have this same kind of notation. That means sine of x. And when you're looking at sine of x, I'm thinking about an inverse function. Remember, to find an inverse function, it has to show a reflection of a line y is equals to x. So let me start from the basics here. I start with the sine function. Y is equals to sine of x. So you can see this function continues indefinitely. The domain is negative infinity to infinity, and the range is from -1 to 1. So here, for me to be able to find an inverse function, it must be 1 to 1. What does that mean? It must pass the horizontal and vertical line tests. And what does it mean by vertical line test? If I make a line, a vertical line, and you can think about all these lines on the graph, each line touches the graph once, so that means it passes the vertical line test. However, if I do the horizontal lines, they cut the graph at many times. So it means this graph or this function is not 1 to 1. The only way I can be able to make it 1 to 1, and why do I need to make it 1 to 1? So that I can be able to find its inverse, is to restrict the domain. And we restrict the domain by having the domain start from -π/2, which is the same as -90 degrees, to 90 degrees, which is π/2. And you can see the restricted domain. Now, if I do the horizontal line test, you can see the graph passes. If I do the vertical. If I do the horizontal, it does pass too. So it's 1 to 1. So now I'm going to find the inverse of that. Remember, we find the inverse by interchanging the domain and range. So this is the inverse. That's how we write it. See, the domain is now what was the range of the original function. And you can see the range is what was the domain. So when I interchange those and graph it, you can see how the inverse looks like. And what I want us to notice here is that the inverse is defined only in 2 quadrants. And these quadrants are going to be, remember, in this range, this is the range where the domain is defined. And this range is quadrant 1. So this quadrant 1, and quadrant 4. There is no other place where the sine inverse is defined. So it has to meet the two criteria. It has to be in this quadrant, and it has to be between -π/2 and π/2. The other thing I want to point out here is that the sine inverse is also called arc sine. You can see it right here. So let's do some examples. And as you do these examples, use your unit circle. We are going to find the sine inverse of sine of square root of 3/2. So what does it mean? We are looking for the angle whose sine value is square root of 3/2. And I'm going to write those angles. So those angles from the unit circle are, I see 60 degrees, and I also see, I'm just looking at square root of 3/2, and I also see 120 degrees. 120 degrees. Do I have another one? No, that's it. So now I just go back to my criteria, and what does my criteria say? So I have these two choices to choose from. It has to be in quadrant 1, or quadrant 4, and it has to be within that range. So the only angle which satisfies this condition is 60 degrees. So 120 degrees does not satisfy, but 60 degrees does. And 60 degrees, remember, is the same as pi over 3. So that is the answer for the first one. Let's go to the second one. And the question is asking, what is the angle whose sine value is 1.5? So I'm going to look at my unit circle and write all those angles whose sine is equals to 1/2. And I can see I have 30 degrees. And what is the other angle? And I also know that sine is only positive in quadrant 1 and 2. So the other angle I'll be looking at is in quadrant 2. So I have 150 degrees. And again, I look at the criteria given, and what does it say? The angle can only be in quadrant 1 or 4, and it has to be between negative 90 and 90 degrees. So this angle has to be 30 degrees, which is the same as pi over 6. So that's the answer. Let's go to the next one, and this one I just wrote arc sine so that you keep remembering that's another way of writing the sine inverse. So this one I'm looking at the angle whose sine is -1/2, and this can only be in quadrant 3 or 4. And let me write those angles in quadrant 3 and 4. And in quadrant 3 I have 210 degrees. And in quadrant 4, I have 330 degrees. And in the same quadrant 4, I have -30 degrees, because that's also in quadrant 4, -30 degrees, which is the same as, which is coterminal, not the same as, it's coterminal with 330, but it has the same value. Now I look at my criteria, and 210 is in quadrant 3, so that one is out. 330 is in quadrant 4, so that's good. But is it between negative 27, remember negative 90, so negative 90 and 90 degrees? No, it's a big number, so it cannot be 330 because it's not between negative 90. Remember, this is negative 90 degrees and 90 degrees. So it has to be within those numbers. So it doesn't. So the only answer possible is -30 degrees or negative pi over 6. So here we do another example. We do the arc sine of square root of 3/2. And here I'll be focused in quadrant 3. So one of the angles is going to be 225 degrees in quadrant 3, and the other angle where sine is negative square root of 3/2 is 315, and also in the same quadrant I have -45 degrees. Those are all the possible angles, and the angle has to be in quadrant 1 or sine inverse is only defined in quadrant 1 and 4. I have to keep remembering that. And I have to remember the other criteria. It has to be between -90 and 90 degrees. So it cannot be this one, cannot be that. So it can only be -45, which is the same as -pi over 4. And the other values we need to be familiar with is sine of 0. What is sine of 0? So sine inverse of 0. And this is going to be 0 degrees. Remember, it cannot be 2 pi because 2 pi is not within the range, but it is 0 degrees. And do we have it? So that's the only value we have. So 0 degrees or 0 radians. And then what is the angle whose sine is 1? And that angle is 90 degrees. I'm just looking at the unit circle, or pi over 2. because that's within the range, because it has to be within the range of negative 90 to 90 degrees. So that's the answer right there. And the next one is sine of negative 1. So can it be 270? So it could be 270 or it could be negative 90. But see, 270 is not between negative 90 and 90, so it cannot be that. So it has to be negative 90 or negative pi over 2. Okay, so let's move on. So now let's consider the cosine. So this is the cosine function. This is the cosine function. I need to cross this out. So this is the cosine function. And in the cosine function, you can see the domain is all real numbers and the range is negative 1 to 1. Again, it passes the vertical line test, but does not pass the horizontal line test. So that means it's not 1 to 1. I cannot be able to get its inverse unless I restrict the domain. So for this one, we restrict the domain from 0 to pi. And you can see when I graph it here and find the horizontal and vertical line test, you see this graph passes. So that means I can be able to get its inverse. So I switch the domain and range and then graph it, and you can see. But the most important thing here is this range, because this is what is going to help us. So from 0 to pi. And what does that mean? For the cosine function, the inverse is only possible in quadrant 1 and 2. And that is between 0 and 180 degrees. It's not possible anywhere else. So quadrant 1 and quadrant 2. Okay, now let's look at some examples here. So here we have cosine inverse of half. So what is the angle whose cosine is half? So let me write all the possible answers down. So I have 60 degrees in quadrant 1. And I'm looking at cosine. So the other positive value is going to be in quadrant 4. So this is going to be 300 degrees. And I have to remember that the cosine, inverse cosine, is only possible in quadrant 1 and 2. So 60 degrees is in quadrant 1. So that's the only one possible. And remember, this is the same as pi over 3. 300 is out. Let's go to the next one. The next one, we are looking at cosine inverse of negative square root of 3 over 2. And this is going to be in quadrant 2, 150 degrees. I'm going to write all the possibilities. 150 degrees. Also, it's also in quadrant 3, which is equals to 210 degrees. And those are the only two values which are negative. Then I just have to remember the condition. It has to be between 0 and pi, or 0 and 180 degrees, or quadrant 1 and 2. So this one doesn't meet that criteria. So this is the only one which meets criteria, 150 degrees. And 150 degrees is the same as 5 pi over 6. So that's the answer. Okay, now some more examples here. Cosine inverse of 0. What is the angle whose cosine value is 0? So do we have that angle whose cosine value is 0? So I'm going to look at the possibilities. So I have 90 degrees. I see the cosine is 0. And I see 270 degrees. And which one is in quadrant 1 and 2? So it's only 90 degrees, which is the same as pi over 2. Now let's go to the next one, cosine inverse of 1. So which argos have a value whose cosine is 1? And this is going to be 0. What about cosine inverse of negative 1? That's going to be 180 degrees, and which is the same as pi because it's within the range. So here now we consider the tan function. You can see it does not pass the horizontal line test. So we have to restrict the domain from negative pi over 2 to pi over 2, just like for the sine. And now when we interchange the domain and range, you can see these two functions, the function with the restricted domain and the function, the inverse function, they pass the horizontal and vertical line test. So now what we need to note here is that tan is only defined in quadrant 1 and 4. 1 and 4 only. And remember, it has to meet the criteria. It has to meet the criteria of the range from negative pi over 2 to pi over 2. So let's do some examples here. So what is the argo whose tan is positive 1? And I know the values. Tan is given by, remember, tan is given by tan of x is given by sine of x over cosine of x. And that means the values of x and y have to be equal. And because the value is positive, it has to be in quadrant 1. So in quadrant 1, what is the argo whose x and y, sine and cosine values are the same? And this is going to be 45 degrees, which is the same as pi over 4. And that's the answer. Now we go, and does it meet the criteria? Yeah, it's between negative 90 and 90. It's in quadrant 1. We go to the next one, tan inverse of negative 1. So that can only be in quadrant 2, which is 135. And the other argo is going to be in quadrant 4, 315. And also in quadrant 4, we have negative 45 degrees. So remember what is the criteria for tan? One that if it has been quadrant 1 and 3, 1 and 4. So this is in quadrant 2, so it doesn't meet the criteria. So this is in quadrant 4, 315, but it's not between 0 and negative, it's not between negative 90 and 90, so it doesn't qualify. So the only one which qualifies is negative pi over 4 or negative 45 degrees, because it has to meet the two criteria. It has to be in quadrant 1 and 4, and it has to be between negative pi over 2 and pi over 2, or negative 90 and 90 degrees. So the next one is square root of 3. So which argo has a tan value of square root of 3? And here I'm going to use let's use a special triangle here, because it's easier than looking at the unit circle. So suppose this is not drawn to scale. Suppose this is 60 degrees. Remember, this is 2, this is 1, this is square root of 3. So what is the argo whose tan is square root of 3? Opposite of adjacent, so it has to be 60 degrees. So 60 degrees is the argo. And see, this value is positive, so it can only be in quadrant 1, and it can also be in quadrant 3. What is the reference argo? Which argo has a reference argo of 60 in quadrant 3? And that's going to be 240 degrees. So of these two, which one qualifies? Remember, the answer has to be in quadrant 1 and 4. So that means this one is out. So the answer has to be 60 degrees or pi over 3. So that's the answer. Okay, we go to the next one. The next one is square root of 3 over 3. And note that square root of 3 over 3 is the same as 1 over square root of 3. And that means this angle opposite of adjacent has to be 30 degrees, tan of 30 degrees. So it has to be 30 degrees because tan 30 is the one which has 1 over square root of 3. And which other angle? We are also going to have an angle in quadrant 3 because tan is positive in quadrant 3. And that angle is going to be 210 degrees. But which one meets the criteria for the range? It has to be negative 90 and 90 degrees. So it's 30 degrees. And 30 degrees is the same as pi over 6.